All right, welcome you guys. Thanks for joining me. Today we're going to talk about rational and radical equations. Okay. All right, so we know that we don't have to work with fractions if we don't want to. Okay, so as long as we have an equation here, we'll talk more about that in a second. So just to kind of let you know, these are called rational equations because the word ratio actually means a fraction. So ratio is the root word here for rational. So they're basically just saying fractional equations. Okay. All right. So the way that we get rid of the fractions so that we don't have to work with them is we multiply by the LCD, the least common denominator. And honestly, any common denominator will work. You know, maybe you didn't see right here that 6 is the common denominator, but you could see 12. That's fine. Roll with any number that all of the elements in the denominator will divide into, right? 3 would divide into 12, 2 would divide into 12. Okay, then you can use it. Okay. If you find the least, it's going to make your math a little bit easier. Your numbers will be smaller. You won't have to reduce fractions in the end. So that's why we try to find the least common denominator. All right. So our least common denominator here is going to be 6 because that is the smallest number such that 3 divides into it and 2 divides into it. So we're going to take 6 and we're going to multiply it by all of the numerators. And I'm not actually going to distribute. I'm going to reduce before I distribute. So 3 can go into 6 2 times. And so we end up having 2 times x minus 8. And this would be where we would proceed to distribute. Okay. Same thing on this next one. 2 goes into 6 3 times. So we're going to be distributing in a 3 into that x minus 3. And then 6 times 0 is just 0. So it goes from, you know, being kind of a scary equation to solve to this, which I think we're at this point in the game pretty good at. Okay. All right. So we're going to go ahead and distribute. Combine like terms. So 2x plus 3x is 5x. And negative 16 minus 9 is negative 25. We'll go ahead and move that 25 over to the other side, making it a positive. And then we will divide by 5. So x equals 5. Now we do not have to check on this particular rational equation because there were no variables in the denominator. You only need to check okay, only if there's variables in the denominator. All right, let's try the next one. So this is basically saying what we just said. Since division by 0 is not possible, we have restrictions if there is a variable in the denominator. To find restrictions, set all denominators equal to 0 and solve. Okay, so remember, if I have like 5 divided by 0, that's undefined. If I have 0 divided by 5, that is defined. That's 0. So if we have something like 5 over x plus 1 in our problem, well, x cannot be negative 1. If x were negative 1, right, and we substitute a negative 1 in, what we end up getting is 5 divided by 0. So we end up getting something that's undefined inside of our equation, inside of our problem. Okay, so like it says up here in the top, set all denominators equal to 0 to see what x cannot be. So I just told you it was negative 1, but if you can't see it, you can always set it equal to 0, and then you're going to see it can't be negative 1. Sometimes you can get away with just thinking, okay, well, what would make this 0? Well, negative 1 plus 1, 0. Okay. All right, so let's go ahead and see what this looks like. So now we have rational equations where there's a variable in the denominator. So that means there's a possibility the denominator could go to 0. So the first thing we're going to do is we're going to get our restrictions by setting x plus 3. Well, we're going to say x plus 3 cannot be 0. We cannot have a 0 in the denominator. And then we will solve that. So we'll bring our 3 over to the other side. So it looks like x cannot be -3. And a lot of you will just be able to spot that without doing any math. You could just be like, yeah, -3 plus 3, 0. So that's going to be my restriction. The next thing we want to do is we want to find out our LCD, right? Okay, so our least common denominator, well, there's only one thing in the denominator, an x plus 3, right? So that is going to be our LCD. So remember, we're going to take that least common denominator and we're going to multiply it by all of the numerators. So let me just move this down a little bit so I don't feel so squished. So I'm going to multiply this numerator by x plus 3. I'm going to multiply this one by x plus 3 and this one. Now remember, the whole goal is to get rid of the fractions. So we're going to go ahead and cancel the x plus 3's. We're not actually going to multiply. We're going to cancel the x plus 3's. So this did get rid of the fractions. All the denominators went away. So what remains is x plus 6 minus 2 times x plus 3 equals 3. All right, so here we go. We're going to go ahead and distribute that -2. Combine like terms. So 1x minus 2x is going to be -x. And then the 6 and the -6 will just cancel each other out. And so we end up with 3. And I'm going to divide by a -1. So we end up with x equals -3. Now, notice, it's kind of a problem. That is our restriction, right? Okay. So x equals -3 will not be a solution since it is a restriction. So what that means is that for this particular equation, there is no solution. Okay, so we're going to go ahead and just put the empty set. We'll write no solution just in case you have a drop-down menu on your online platform, or we'll also just put the empty set. All right, let's try the next one. So a couple cautions. You can only multiply by the LCD if it's an equation, not if it's an expression. So I have some students who will have something like this. Let's just say x over x plus 3 plus 6 over x plus 1. And it's an expression. There's no equal sign there. So they'll multiply by the LCD to get rid of the fractions, right? And this would all be completely incorrect. You cannot, on an expression, just go in there and start canceling the fractions. This would be wrong, okay? And I think an easy way to see that is maybe put the numbers back. If I have 1/2 plus 1/4, okay, we're going to do it the right way. The right way would be to get common denominators. So this is going to be 2/4 plus 1/4. So the correct answer is 3/4. But if I take this expression, notice there's no equal sign, right? Okay. And I go in here and I'm like, I'm going to multiply by 4s to everybody so I can cancel the denominators out. 2 goes into 4 twice, and 2 times 1 is 2. And then these would cancel, so they'd get us 1, and we get the answer of 3. So that's problematic, right? 3 does not equal 3/4. So this is completely wrong, you guys. Okay, you can only do it if there is an equal sign. And I'll show you that that makes more sense by just doing it with numbers again. If I have 1/2 plus 1/4 and there's an equal sign, and we know the answer is 3/4, then when I multiply by the LCD of 4, what will remain is a true statement, okay? We know that 2 goes into 4 twice, and 2 times 1 is 2. We know that the 4s will cancel here and here. So that's just going to leave us this 1 and this 3. And that's a true statement. 2 plus 1 equals 3. Yeah, so this is true. Okay. So it's okay if it's an equation. And the way that we can tell that it's an equation is it started with an equal sign, right? Okay. It's not okay if you have an expression though. Okay. All right. So multiplying by the LCD can cause extraneous solutions. So you must check when solving rational equations that have a variable in the denominator. Okay. So we got to make sure we check. We didn't check on the last one because we didn't have any solution to check, right? No solution, so we don't need to check it. All right, let's go in here and get our restrictions. Now, we are going to set the denominators equal to 0, but this one we need to factor first. Okay, so let's factor first. It'll make it easier to see our restrictions. Okay, and it's also going to make the math easier just all around. Let's go smaller. Okay. All right, so what we're going to factor is we're going to factor that y squared plus 2y minus 3. So we're looking for factors of -3, so things that multiply to make -3 and add to make 2. So it looks like it's going to be 3 and -1. 3 times -1 is -3, but 3 plus -1 is 2. So the factorization for this quadratic is going to be y plus 3 and y minus 1. So we can take our original problem and rewrite it in the following way. Okay, so now it's just so much easier to get these zeros, right? We have to set the denominators equal to 0 to get our restrictions, right? So we're going to set y, we're going to say y minus 1 cannot be 0. Y minus 1 can't be 0 because we can't have zeros in the denominator. Y plus 3 can't be 0. And it looks like we just have repeats, huh? Y minus 1 and y plus 3. So we'll just solve these two equations. It looks like y cannot be 1 and y cannot be -3. And again, you could probably just see it. Like if we were to substitute a 1 in there, 1 minus 1 would be 0. If we were to substitute a -3 in there, we'd get a 0. Okay, so now we need to have the LCD talk of what's going to be the least common denominator. It's actually easier when you have polynomials in the denominator because basically any factor you see, that's going to be part of your LCD, okay? So there's a y minus 1 and there's a y plus 3. That's going to be our LCD, okay? I wouldn't need to put it to a higher power unless like one of them was squared. Then you would take the highest power that you see. So I would make it squared here. But since they're all to the first, then we're just going to keep them to the first in our LCD. Okay, so we're going to be multiplying by y minus 1 and y plus 3 to all of the numerators. All right, so we can cross off the y minus 1s, the whole thing here, and the y plus 3s. So this is going to leave us with y plus 3, which is just multiplying by a 1. So it's going to stay y plus 3. It's going to leave us with a y plus 1. Sorry. And then it's going to leave us with a 1 multiplying by y minus 1. So it's just going to stay y minus 1 because multiplying by 1 doesn't do anything. All right, let me just check through my work really quickly, you guys. Make sure everything looks good. Yeah. Okay, let's do this. So I'm going to combine like terms on the same side of the equal sign. So y plus y is 2y. And 3 plus 1 is 4. And I'm going to move the smaller variable. So I'm going to subtract y just to keep things positive. And then we'll subtract the 4 over. So we get y equals -5. Just stare at stuff, make sure everything looks good. Yeah. Okay, we'll find out right now because we're going to check it, right? Now we get to, this isn't one of our restrictions. Okay, so now we just need to proceed to check, right? So we're going to go ahead and take -5 and we're going to substitute it into, and we'll probably substitute it into this one down. You could substitute it into the original. Maybe I'll do that just because I think that's what most people would do. So let me get a picture of this. Let's go to a new slide. And we're going to check -5. Okay. 1 over -5, take away 1. There's just a string right there. There we go. Plus -5 plus 1 over . There we go. So this is going to be 1 over -6. When we combine these, we're going to get -4. So -4. -5 times -5 is 25. 2 times -5 is -10. So we get -1/6. I'm just going to pull the negative sign off to the side. 25 minus 10 is 15. 15 minus 3 is 12. All right. So we want to know if this is -1/2. So we could probably just go to our calculator. I mean, I'm allowing calculators in the class, right? So let's use it. So negative sign, 1/6, and then -4. Oh, I should do this. False. Ah, what do you know? We got -1/2. So it does check out. Okay. All right. So it looks good. So let's go back to the previous slide and we're going to go ahead and box the answer of y equals -5. All right, let's try another one. Okay. So we set the denominators equal to 0 to get our restrictions. So we're going to set x, or say x minus 1 cannot be 0 and x plus 1 cannot be 0. So it looks like x cannot be 1. And it looks like x cannot be -1. Okay. So now we go and we get our LCD. So every factor that you see in the denominator is going to be represented and to its highest degree, right? They're all to the first power. They all have exponents 1 that we don't write. Okay, so I'm only going to write them one time. Even though x plus 1 shows up twice, you're only going to write it once, okay? All right, so that's what we're going to multiply all of the numerators by. And x minus 1, let me just write this a little bit lower, you guys. And then x plus 1. X minus 1. X plus 1. We're just going to start canceling. So we're going to cancel the x minus 1s, the x plus 1s, and the x plus 1s. So this leaves us with an x plus 1 right here. It's multiplying by 1, so nothing's going to happen. We've got our -2x, but we also have an x minus 1. Oops. And then 2x minus 1. 2 times x minus 1. All right. So we're going to go ahead and distribute. This is going to get us -2x squared. A negative times a negative is a positive. That'll get us 2x. And that'll get us 2. All right, so I'm going to write it from highest exponent to lowest. So there's the 2x squared. Now we have to combine these x's together. 1x plus 2x is going to get us 3x. And it looks like our only constant is the plus 1. Now I want to keep my my x squared positive. So I'm actually going to move this over to the other side so that it is positive. And that means I'm going to move everything over to that side. So I'm going to move the 3x over, and I'm going to move the 1 over also. That way we have 0 equals. Okay. All right, so this is going to be an AC method problem. So we're going to use the AC method right now for factoring, right? We could use the quadratic too, but we'll try the AC. So we're going to do 2 times -3, a times c. And that looks like that's going to get us -6. So we're looking for things that multiply to make -6 and add to make -1. All right, so that's going to be, let's see here. Thinking -3 times +2. -3 times +2 is -6. -3 plus 2 is -1. So remember, everything stays the same. The front and the back stay the same. Just this middle term is going to be re-expressed using those two numbers we just found. -3x plus 2x is -1x, okay? And keep the -3 at the back end the same. So you're just re-expressing that middle term right there. All right, and then factoring by grouping, we're going to slice this down the middle, and we're going to take out the greatest common factor from each half. Looks like only an x can go into this. And you have to take something out, so we're going to take out a 1. That's the only thing we could take out that won't change the value. And we don't want to change the value because we want these to match, and they do. So that is a good sign. So the parentheses is one of your, the 2x minus 3 is one of your parentheses. And then the leftovers, the x plus 1 is the other. Now, using the principle of zero products, we're going to set each piece equal to 0. And let me see how I'm doing for space on this slide. Okay, I can probably move this up here. So if we set each piece equal to 0, we'll move the 3 over and divide by 2. We get 3 halves. Now, since that is not a restriction, we're going to go ahead and keep it for now. All right, and then we're going to move the 1 over, and this is problematic because we just got done saying up here, x cannot be -1. So that means that we're going to go ahead and get rid of this. It's not a solution since it's a restriction, okay? This will not be a solution since it's a restriction. All right, now we still have to go and check the negative or the 3 halves and make sure that 3 halves works, right? Okay, so I'm going to go ahead and just copy the original problem and go to the next slide. And let me check 3 halves. Okay, so we're going to go ahead and check 3 halves, right? And you could put this all in a calculator. I'm going to do it by hand, but by all means, if you want to just put it all into a calculator, you can. Those 2's are going to cancel, so that's going to give me a nice number. Okay, it's going to give me 3. So I definitely want to try to do that before I go to a calculator. Okay. All right, so now I'm going to clean up those denominators. 3 over 2 minus 1 versus 3 over 2 plus 1. So you're always going to put a 1 underneath, and then you're going to multiply to get common denominators. So this is going to be 3 over 2 minus 2 over 2. So this is going to become 1 over 2. So over here, it's the same math. This is going to be 3 over 2, and this is still going to be 2 over 2. The only difference is it's going to be a plus sign, right? So this one will become 5 halves, and these two match. So it's going to be 5 halves for the next one. Okay. Now, if you want to go and put it in a calculator now, you can totally do that. So let's go ahead and do that really fast just to kind of show you what that looks like. And I'll talk more about that too the long way. All right, so let's see what that looks like. All right, so the very first one that we were doing is 1 divided by a half, right? So you'd hit 1, and then, okay, so you're going to get 2 for that. Now let's talk about, because I know a lot of my students would just do this on the calculator, that's why I was showing you it. But what's really happening when you're dividing with fractions is you are actually 1 divided by a half written out, 6th grade style. You're flipping the second fraction and you're making it a multiplication problem. So if we flip 1 over 2, it's going to become 2 over 1 or just 2. And that's how you end up getting the 2 super fast, right? Okay. So on this one, it would be 3 over 5 halves. Well, that's 3 divided by 5 halves. That means it's 3 times 2 over 5 because you have to flip it. So if we multiply with the 1 underneath, that's going to get you 6/5. Now you could totally put this into the calculator, right? What was it? 3 divided by 5 halves. So it's going to be 3 over 5 halves. There's your 6/5. Okay. All right. So the next one, which is 2 over 5 halves. Well, that's going to be 2 times, 2, we could probably skip to it. 2 divided by 5 halves. So that means 2 times, flip it, 2/5. You put a 1 under the 2 and you multiply straight across. 2 times 2 is 4. 1 times 5 is 5. So this is going to be 4/5. Okay, so if we take 6/5 away from 2, the question is, are we going to get 4/5? 2 minus 6/5. 4/5. It worked. All right, so this side's 4/5. This side's 4/5. It's a keeper. Okay. All right, so let's go back to the other slide and let's go ahead and box. And you know what? I probably should be writing see next slide for checking, right? Yeah. All right. So this is going to be us checking. So example 4. All right, example 5. So as usual, you do want to factor first, just like we did on the last one, right? We had this on the last problem, or no, it was the problem before that. We had this, polynomial, this quadratic polynomial that we factored first. But we're going to do the same thing here. We're going to take all of our denominators and we're going to factor them. So 3x plus 6, we can take a 3 out. So that's going to be our denominator for the first term. All right, now x squared minus 4 is a difference of squares. So easy to factor difference of squares. We basically just square root this last number. So it's 2. So it's going to be 2's. And then you just make sure that they have opposite signs. Okay, so that's the quick way of whenever you have a perfect square with a minus, right? A difference of squares, okay, that you can factor. And this has to be x to the, some even number, x to the second, x to the fourth, right? Okay, so 1 over x plus 2, x minus 2, and this one's already fully factored. So now the reason why we want to factor it is now it's so much easier to get our restrictions. So we're going to set this equal to 0, which you can probably see which value would cause that to be 0. Okay, x plus 2, well, we kind of already did x plus 2, but I'll just do it anyways. And then x minus 2. These are all the things that we see in the denominator. Now, when you can divide this 3 out, so it becomes irrelevant. So it's really just you setting x plus 2, equal to 0. So you're going to get -2. And you can see this is the same math, right? So this one's also going to be -2. But this one, when we add the 2 over, it will be +2. I need to make better, not equal to signs. There we go. All right, so x can't be 2 or -2. You could just say to yourself, what could I plug in here to make a 0? -2. What could I plug in here to make a 0? -2. Here, +2. Here, +2. All right, now LCD time. Now we have to put everything that we see in the denominator, right? So the LCD will have a 3. It'll have an x plus 2, and it'll have an x minus 2. All right, so we're going to go ahead and multiply all of the numerators by 3, x plus 2, x minus 2. Okay, so let me cancel all the common terms with the numerator and the denominator. Oh, that feels nice. Love canceling all that. All right, so here is what survives. We've got a 2 and an x minus 2. Just a 3, because 3 times 1 is 3. And then 4 times 3 is 12. And I mean, this method's so great because this equation compared to the original, so much easier. I hope you just take a moment to stop and appreciate that, you know? All right, here we go. So we're going to go ahead and multiply by 2. Combine like terms. All right, we're going to move the smallest variable. So I'm actually going to subtract 2x just to keep my numbers positive. So we'll take away 24 from both sides to try to isolate the x. So we get -25. And then we'll divide by 10. X equals, now if you have -25/10, the common factor would be 5. So we're going to divide through by 5s, which will get us -5 halves. Now it's not a restriction, so it's possible that it's a solution, but we are going to go and substitute it in and check it right now. So let me go ahead. And it was negative, right? Yeah. Okay, so -5 halves. Let's check it. All right, so we're going to substitute -5 halves in. Okay. All right, I might just use the calculator just to get things moving along a little bit more quickly, you guys. Okay. So I'm just going to use the calculator to figure out these denominators, okay? So it's going to be 3 parentheses -15/2. I'm sorry, what am I talking about? -5/2. Right arrow to get out of the denominator, and then +6, right? All right, so that's me substituting in this denominator. All right, then we're going to go ahead and do this denominator in the middle. So we've got -5 halves squared. So 25, oh, sorry, -4, right? Forgot the -4 part, you guys. -4. 9/4. And then -5/2. -5/2. Take away 2. All right, so -9 halves. All right, so if we plug these into the calculator or use the flip and multiply technique that we just talked about a second ago, right? 2 divided by -3/2 means 2 multiplied by this. So that's where I'm getting the -4/3, you guys, by putting a 1 underneath. Okay. And flip and multiply here. So it'll become 4/9 instead of 9/4. And flip and multiply here. It'll become that. And you could just put this into the calculator to get each one of these. All right. So then if we go ahead, we can put it in the calculator or get common denominators, whatever works for you, fits your class. Indeed, this does equal -8/9. Okay. All right. So it checks out. So we are going to keep this solution. All right, so before we go and solve these radical equations, let's make sure that we know what the parts are and how to talk about them. Because I don't just want to say words like, oh, equal to the index, and we don't know what the index is, okay? So the part underneath the radical is called the radicand. And I'll definitely use that word a lot in the class, okay? The entire thing is called a radical, and then this symbol right here is called the radical symbol. Now, in this particular section, we're going to use this a lot, the index. So the index is telling you what kind of a root it is, right? Since there's a 3 here, this is a cube root. If there's nothing there, it's a square root. So you just kind of have to know if it looks like that the index is a 2, okay? And just to make sure everybody understands, when we have a square root, we're saying, okay, what number times itself twice gets you that number? Like, let me do 64 as an example, okay? And so that would be an 8, because 8 times 8 is 64. But if I have that same number 64 and the index is 3, then I'm saying what number times itself 3 times gets you 64. And that would be 4 for the answer, since 4 times 4 gets you 16. And if you multiply it by another 4, you get a 64, okay? So that index is saying, okay, well, how many times am I going to multiply the number, right? Okay, so let's go through these steps. And every time I do a problem, I'm going to kind of refer back to these. So step 1, isolate the radical. So if you look at an example like this first one, example 6, the radical is not isolated. There's this +3 that's not underneath the radical that we would have to get rid of before we could proceed. Now it says more, it says isolate the radical. If an equation has more than one radical, choose one of the radicals to isolate. So for example, this one right here, we could really isolate either one of these. Now, this one's already isolated, so I would pick that one, right? But if we wanted to, we could isolate this one instead. It just says pick either one, okay? All right, raise each side of the equation to a power equal to the index. So if we have an index of 3, if we have a cube root, then we're going to raise to the power of 3. We're going to cube it. If we have a square root, then we're going to square it. If we have a 5th root, then we'll raise it to the 5th, okay? All right, then just a generic solve, that could entail anything. But sometimes on step 3, we still have a radical remaining. In that case, you got to go all the way back up to step 1 and start over again, okay? And then step 4 is huge. I always miss these questions because I forgot to check. I couldn't remember when I needed to check stuff. So we do get extraneous solutions when raising both sides to an even power. So technically, if it's odd, we don't have to check it, is what this is saying. So on a cube root, if you cube both sides, you don't need to check it. But if you raise it to the power of 2, 4, 6, 8, any of those even numbers, then you do have to check that. Okay, and I'll talk about that as we go through. I'll be like, do we need to check this or not? It's just to make sure that you guys know when we do and when we don't. Okay, so let's go ahead and start with example 6 here. So step 1 is to isolate the radical. So in order to isolate the radical, we're going to have to move that 3 over to the other side, making it a -3. All right. And then step 2, raise both sides to a power equal to the index. And it's important that you use parentheses here so that you understand that this whole quantity right here is being squared. Okay. All right, so the square is what cancels out the square root, right? These are going to cancel with each other. So we're just left with x minus 1. Now over here on the right-hand side, we're going to have to distribute or FOIL out this x minus 3 times x minus 3. Negative times a negative is a positive. All right, let's go ahead and combine like terms. Okay. So we have to get all of the variables, all the terms, sorry, on one side because we have an x squared and an x. So that tells me I have to get everybody on one side. So we're going to go ahead and subtract the x and add the 1. Subtract the x and add the 1. So that way we get a 0 over here. Most of the time, 9 times out of 10, if you have an x squared, you do need to get everybody on one side, okay? All right, the only case you wouldn't is if you only had an x squared, something like this. Then you could move the 4 over and not have all the terms on one side, square root, right? So that's the case where you wouldn't necessarily want all the terms on one side, but usually, guys, 9 times out of 10, if there's an x squared, get everybody on one side. All right, so we got x squared minus 7x plus 10. And I'm going to factor because they're usually kind enough to give you something factorable. So we're looking inside of these larger problems. So we're looking for factors of 10, things that multiply to make 10, that add up to negative 7. So that's going to be negative 2 and negative 5. Negative 2 times negative 5 is positive 10, but negative 2 plus negative 5 is negative 7. Since the leading coefficient is 1, we don't have to do the entire AC method. We can go right to the parentheses. Okay, using the principle of zero products, we're going to set x minus 2 equal to 0. And we're going to set x minus 5 equal to 0. So if we move the 2 over to the other side or add it over, we get 2. And if we add over the 5, we get 5. Now, we can't box these yet. Remember that step 4 is to check. So we still need to check. So over here, we will do our checking, okay? Now make sure that you check in the original. If you check somewhere else along the way, you might end up getting that they are correct answers when they're not. So don't pick any random line to check in. We're going to check it in the very original. So this is us checking x equals 2. And then over here, we'll check x equals 5. All right, so let's go ahead and substitute 2 into the original. Might have gotten a little large there. All right, 2 minus 1 plus 3. And then a 2 here also. So 2 minus 1 is just 1. The square root of 1 is 1. And 1 plus 3 is 4, which does not equal 2. So that means that 2 is an extraneous solution. Okay, x equals 2 is extraneous. Okay, so let's go ahead and try with 5 and see if that works out better for us. Okay, so we're substituting 5 into the original. Five minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. Sorry, guys. All right, so this one checks out, which means we're going to keep x equals 5 as a solution. Okay, let's go ahead and go through and try another one. Now, the reason why we had to check because we squared both sides, and we said anytime it's even, that you raise it to an even power, you need to check. So I'm going to put a little note right here. We need to check since it's even. Okay. All right. Okay, step 1, isolate the radical. So we are going to have to, I'll probably just do it this way. We're going to have to subtract 8 from both sides to isolate that radical. Okay. Now, step 2, raise both sides to a power equal to the index. So since our index is 3, we're going to raise it to a power of 3, and that is what is going to cause these to cancel out with each other. So we just have 6x plus 9, super nice. And then negative 3 times negative 3 times negative 3, right? So we get positive 9, which we have to multiply by a negative 3. So we get negative 27. All right, so let's go ahead and subtract 9 from both sides. Then we'll divide by a negative, or divide by a 6. So negative 36 divided by 6, that'll be negative 6. Now, the question is, do we need to check? We do not need to check because we raised both sides to the power of 3. Okay, so we do not need to check since we raised both sides to an odd power 3. So that makes it so much shorter, right? Not having to check. So we're going to keep negative 6. We know it works. Now you can always check. If you're the type of person who just litters the page with mistakes, in other words, me, then I would probably check. I trust myself very little, you guys. All right, so you can always check, okay, but you don't have to if you feel pretty confident on whenever you're raising to an odd power. Okay. So here's the hardest one on the notes. There's one like this on our final exam review, and it's honestly the hardest problem on the review and the hardest problem on the final. So if this makes sense to you, great. Okay. But if it doesn't, like, okay, that's totally normal. You know what that means. You just got to do more of them. Okay. And I promise after like 3, probably, maybe 4, you'll be like, okay, I get this. Okay. Now, part of what makes it hard is it's just long. The students don't like to spend this long on a problem. But hopefully it makes sense. And we'll make sure that we check our answers, right? And that we go through those 4-step process. So step 1 is to isolate the radical. If there's more than one radical, then pick one of them to isolate. So I'm going to pick this one because it's already isolated. Okay, so step 1's done. Step 2 is to raise both sides to a power equal to the index. There is no index, which means it's a 2. Okay, no written index. So we're going to raise both sides to a power of 2. So that means that we're going to go ahead and cross off here to get 1 minus 2x. But over here, we're going to have to square this. So we're going to have to multiply it 2 times. We're going to have to multiply it by itself. One thing I want to say is a lot of students will just square each piece. They'll be like, okay, that's a 4, and then the square root's gone. It is not a property that if you have the a plus b squared, that you can just put the 2 on both, okay? Now, if you're on a test and you're like, oh, is this true? Is this a thing? With the variables there, it's kind of hard to see it. Put some numbers in to check and be like, can I just do that? Let me see. And you'll find out right away, if it's a thing or not. So here we would get 5 squared. 2 plus 3 is 5. 5 times 5 is 25. Over here, we get 2 times 2, which is 4. 3 times 3, which is 9. And we end up with 13. So this is not a thing, you guys. So don't just, when you're adding or subtracting, go in there and just square each piece. You've got to distribute. You got to FOIL it out. There's going to be an outer and an inner that you would be missing if you just did each piece. All right, so we get 2 times 2, so we got a 4. 2 times the square root of 1 minus x. Well, we can't distribute that 2 inside. If it had a radical on it, then we could distribute it inside. It doesn't, so we have to leave it as is. Same thing here, right? One's in a radical and one's not, so I cannot combine them. I can't multiply them out. All right, and then we got a root times the same root. So earlier in the class, we said if you have a root times the same root, it just gets you the number inside. Okay, and that's good to know. I mean, when it's 2, it's really easy to be like, well, that's a 4, and that's why it becomes a 2. But if I start getting thing like 139, well, I don't want to be multiplying 139 times 139 when square rooting. Bam, it's 139, right? Okay, so in our case, when we take the square root of 1 minus x times the square root of 1 minus x, it's just going to be 1 minus x. All right, we're going to combine like terms. So I'm going to go ahead and combine the 2 radicals by adding the numbers out front. And then I'm going to combine the constants here. We have a 1 and a 4. That'll get us a 5. And then we have an x, a minus x here that hasn't combined with anybody that we need to bring along for the ride. Now, normally step 3 is just solve, but it does say on step 3, if a radical still remains, to go back to step 1, isolate the radical. So we're going to have to try to get the radical by itself. So we're going to take away 5 and add x. We're going to take away 5 and add x, so we can start to isolate that radical. So 1 minus 5 is -4. -2 plus 1, that'd be -1. Now, I'm not going to fully isolate it. It's okay to have a number multiplying by it. That won't affect the answer in the end. It's addition and subtraction that will. Now, I want to leave it because if I were to divide by a 4, this would give me a fraction here, which is pretty ugly, and I just don't like working with fractions if I can help it. So I'm going to go ahead and leave it as is and consider the isolating the radical step done. Step 2, raise both sides to a power equal to the index. So we're going to raise both sides to a power of 2. So that means that we have to take this -4 minus x and FOIL it out, and that we have to square both the 4 and we also have to square the square root. They're both inside the parentheses, so they're both getting squared. All right, a negative times a negative is positive. Negative times a negative is a positive. It looks like these are all negative times negatives. Four squared is 16. And anytime you square the square root, they will cancel each other out and just leave you the stuff underneath. That's multiplication. There's no symbol, you guys, so that means we're multiplying. All right, let's put this in highest exponent to lowest descending order, but in standard form. So x squared first. 4x plus 4x is 8x, and then 16. And then we'll distribute to 16 over here. All right, so we need to get everybody on one side, right? So I'm going to go ahead and take away 16 and add 16x. So that way those disappear. But that means that I would need to take away 16 and add 16x on the other side as well. So we're going to get x squared plus 24x. And it looks like all of the other stuff cancels out because they're opposites. So it's going to be equal to 0. Now, anytime that you have x squared and an x and no constant, it's not a trinomial. You're not going to factor in the usual way where you're going to use the x, okay? You're going to factor out the GCF. So I'm going to take out an x from both terms. And then we'll set each piece equal to 0. All right, so x equals 0. X plus 24 equals 0. So in other words, -24. Now I'm not going to box these. These still have to be checked, right? That's step 4. After you solve, check. So we're going to go ahead. Now, we don't always have to check. We check if we've raised both sides to an even. Well, if you look back at the very first step we did, we raised both sides to an even. We actually did it twice. We did it on this step here too, but I'm going to write that down. We need to check since we raised both sides to an even power. All right. So because it's getting kind of squished on this slide, I'm going to go ahead and take that to the next slide, you guys. Oops. A little too far. There we go. All right, let's go to the next slide. And we need to check. I already forgot what we got. 0 and -24. So we're going to check 0. Let me make this a little larger. And -24. All right, here we go. So we're going to substitute in 0. Okay, so if we substitute in a 0, 2 times 0 is going to be 0. So basically just the 1's going to stay. 1 minus 0 is 1. The square root of 1 is 1. The square root of 1 is 1. So we get 1 equals 3. Okay, so that means that x equals 0 is not a solution. X equals 0 is an extraneous solution. So let's go cross it off back on our other slide. Okay, so we're going to go ahead and say that this is not going to be one of our solutions. All right, let's try negative 24. So the minus, right? Minus a negative, that's going to become a plus. So this is really 1 plus 24. Square root of 25 is 5. So the right-hand side of the equation is 7. Let's see what happens on the other side. All right, a negative times a negative is going to make that a positive. 2 times 24 is 48. Ooh, I like that number. 1 plus 48 is 49. And the square root of 49 is 7. This one worked out. All right, so we're going to go ahead and keep, let me put an X next to this one. We're going to go ahead and keep X equals 24, negative 24 as a solution. So that's as tough as it gets. I mean, if you're like, oh my gosh, that was so long. Yeah, this is as tough as it gets. Maybe one of the toughest problems in the whole semester, if not the toughest, okay? Just because of its length and a lot of little tricky things, okay? All right, so don't forget to check anytime that you raise both sides to an even power, right? If it's an odd index root, then you will not need to do the checking. All right, guys, thanks for joining me. Take care.